Hello guys, we are back with another lead code problem. We are continuing our series of recursion and backtracking. So let's see today's problem, and the problem is combination sum third. Let's It's a medium question. Let's dive into the question. What the actually question ask. So find all valid combination of k numbers that sum up to n. Okay, that sum equal to n such that the following condition are trues. Only number 1 through n are used and each number is used at most once. Okay, so we can use at most one element one time each number, and you have to return a list of all possible valid combination. The list must not contain the same combination twice, and the combination may be written in any order. Okay, it's pretty similar to the combination sum 1 and 2. Okay, it's totally because in the combination sum second it's also given an array, and in array you can pick only every element only one time, but here you get a unique array, so that's a little bit easy as compared to the combination sum second. Uh, and but here you don't get any array, you have given only value k, which actually shows you can pick three elements from this from 1 to 9. So let's make an array for our sake of ease. I'll make an array int array because I know I can pick the element from 1 to n. So if I have an array, it's better for me. So what I do, for int I is equal to 0, I greater than n, I plus plus, what I actually do, a dot push back I plus 1, and here is 9 or 10, 9, and that's it. It add 1 to 9 into my this array a. So I got the array. So that question is changes to this. I have an array 1 to 9. I have to choose only 3 elements from this 1 to this array A, only 3 elements, and that these 3 elements sum will be equal to 7. So that's pretty much. If you think you can solve with using the loops, you can definitely solve this problem by using the u loops, but there is a catch. uh, here if here but there is a one catch here. uh, yeah, you definitely solve this problem, but you have to make a different function. For if k is equal to 1, you have a different function. If k is equal to 2, you made another function. K is equal to 3, you made another function. K is equal to 4, k is equal to 5, till k is equal to 9. So your code actually is lengthy. You are doing the repetition work, and you don't know about which code going to run, so you make if else case too. So it's a hectic code. You can definitely solve this problem, but that's a much more lengthy. So for removing such type of thing, and it's totally hectic too, so I don't go with that. So I can solve this problem with the recursion, because here is a catch. I have a choices. Either I pick the element or I left the element. So whenever I have a two choices, and here I see whenever I pick any element, I actually what I do, I'll break it into sub problem. If I pick the element, I'll subtract it to my here is the n, so I'll subtract this value from this n, so my n value going to decreases. So that is actually shows that's divided into the sub problem, and if there is a sub problem part is have in occur, so it means I can solve with the recursion. So that's pretty much about why I'm using recursion here. So I have an error. So what I actually do, I assume this is my solve function. When I call my solve function, it actually store. Okay, first and foremost I have to make my globally vector into ans. When I call my solve function, what this solve function actually does, it store all the unique possible valid combinations and store into this ans. After storing to the ans, I have to return it this ans. That's my job. That's it. This is a job which I have to do. So after that, what I do, I have only one duty. I have to complete my this solve. So how can I complete? I have to pass some parameters. So I'll just start with this array. I'll pass it this k. I'll pass it this n. This n is the target sum, you can say, because in the combination first and second you use the target sum. If I call this n as a target sum, it's you can easily understand what I actually want to say. And any other parameter needed to, yeah, let's point pass it the starting index. Okay, I'll pass it starting index and something else. Yeah, actually I store the a vector into my ans, so I make a vector, temporary vector, let's temp. I pass it here. So last but not least, this temp. So I guess that's a pretty much about my solve. Let's complete this solve function. So it's a void type because it doesn't return anything. So let's make it. So first parameter is vector int a, another is k, another is, let's name it target sum. Next one is index, let's name it idx, and last one is it's a vector temp, vector int temp. Let's resize the id. Okay, there is a condition. If my target sum is equal to 0 and what I actually do here, let's say in this case my k is equal to 3, and what I do, I have an array 1 to 9. So when I pick this one, let's I assume I pick this one and it can contribute on my answer, so I'll pick this one. I decrease this k value for my sake of is for dividing into sub problems. So my k value will be 2, and again I'll pick this 2. I decrease my k value again, so its k value from the 2 it's going to 1. I pick this 4 and I decrease my k value, it now it reaches to 0. So what is actually, so I'll pick my 3 element. Yeah, you can see there is a 3 element. So that means it's my possible answer when my target sum reaches to 0 as well as my k value is equal to 0. In that case, it's possible to make my answer. So in that case, what I do, I'll just push it. What I'm going to push it, actually this is the one of my temporary answer, which is a possible combination which I do some after doing some computation. and it's storing into the temp. So I'll just return in this temp. I'll just start it from here because uh, I guess you solve the combination problem, combination sum first and second. You know what I'm doing here. Okay, and that's it. Let's go with the uh, and here what I do here, I assume it. Let's let's think about simply what I have given. 1 2 3 4 5 6 7 8 9. So that's we have given. I assume my answer will be starting from here. If my answer will be starting from here, I can pick the key elements. I can pick key element from here. If I pick the key element from here, it maybe contribute my answer. So let's say, or I can pick key element from this two. So I pick this, or maybe this. I can pick this key element from here. Okay. So that's my motto. If I try to pick from this here, I can't pick this 2 and 1. Okay. So that's my motto to solve because it redundant the duplication if I do such type thing. So I uh, sorry 9. The idea is actually show the index. So index initially 0. See 9 index is outer bound of array I. So that's why I'll use it 9 here. And that's it. If my array I value is greater than ps, what it's actually mean? It means I can't able to take the element. So in that case, what I actually do, I'll just this not this array, it's a because I'll take it like a. So what I do, I didn't pick this element. I can't pick this element because its value is high. So I'm not going to subtract in anything. And I do one thing. I have to add it one. Just check out for look up for the next possible answer. Uh, check out for the next index. Is it I can add or not? Whether I can add or not. So that's it about whenever my AI is greater than ts. Else if my AI is less than or equal to target sum, in that case what's actually happen? I can either I pick this element or I can't. I can. So let's assume I pick the element. So if I pick the element, my first duty I have to add this into my temporary vector. So I add it into my temporary vector. After that, if I add it, my duty is to make some changes in my array. So my key, if I added, so I have to decrease my key value, and as well as I have to decrease my target sum value to array I and temp key value. And one more thing, I have to enhance my start index idx. So that's it. After doing this is a step when I pick the element. If I don't want to pick this element, I have to remove this from my array. So here what I do, I'll remove it from the array, and that's pretty much about. But when it's going to stop, so I guess it's not needed to add this thing, but yeah, that's it. That's completed. Let's run this code, guys. And that's accepted. Let's submit this code, guys. and that is accepted. So if you have any doubt, let me know in the comment section. I'll resolve your doubt as soon as possible. Until then, keep grinding guys.